Hello everyone, welcome back to the Pre-Algebra review for college algebra, and today we're going to be working on some practice for simplifying radical exponents. So for this, radical exponents are just the same as regular exponents, so we can use the same formulas we discussed earlier. We have the product rule, where x times x to the b equals xa plus b, the quotient rule, x to the a divided by x to the b equals xa minus b, the product rule, x to the a to the b equals x times a times b, and then finally, we have the inverse rule of x to the negative 1 equals 1 over x. Alright, so we have three examples today. Here's the first one. 2x to the 2 thirds times 7y to the negative 4 thirds times x to the 10 over 7 times 4x to the 1 half times x to the negative 11 over 2. Alright, first, we must simplify the 4x to the 1 half by moving the 1 half to both the 4 and the x. So simplifying this gives us 4 to the 1 half times x to the 1 half. Now what we can do is we can split this off into the independent variables themselves and the real numbers. So in the real numbers, we have 2 times 7 times 4 to the 1 half. 4 to the 1 half is equivalent to the square root of 4, which is equivalent to 2, giving us 2 times 7 times 2, or 28. Now, if we move them to x, we have x to the 2 thirds times x to the 10 over 7 times x to the 1 half times x to the negative 11 over 2. Now here, this is just a simple product rule. So we have x to the 2 thirds plus 10 over 7 plus 1 half minus 11 over 2. Here, the main issue is going to be finding common denominators, since that's what we need to do when we add fractions. So if we start with the 1 half minus 11 over 2, we have 1 half minus 11 over 2, giving us negative 10 over 2, meaning we have x to the 2 over 3 plus 10 over 7 minus 10 over 2. Now let's move on to 10 over 7 minus 10 over 2. 10 over 7, we have negative 10 over 2, and we need to find the common denominator. So if we multiply the top and bottom of 10 over 7 by 2, we get 20 over 14. And if we multiply the top and bottom of negative 10 over 2 by 7, we get negative 70 over 14. Next, we can do 20 over 14 minus 70 over 14, giving us negative 50 over 14. Alright, that means we have x to the 2 thirds minus 50 over 14. And again, we need to find a common denominator. So we have 2 over thirds and negative 50 over 14. We can multiply the top and bottom by 14 to give us 28 over 42. And multiply the top and bottom by 3 to give us negative 150 over 42. Finally, we do 28 over 42 minus 150 over 42, giving us negative 122 over 42. That leaves us as the simplified x variable as x to the negative 122nd over 42. Now, let's move on to y. For y, we have just one term. We only have y to the negative 4 thirds. So, y, we have y to the negative 4 over thirds. And this can just be expressed as 1 over y to the 4 thirds. Similarly, x is 1 over x to the 122 over 42. Finally, if we put the real number and both variables together, we get 28 times 1 over x to the 122nd over 42 times 1 over y to the 4 thirds. Multiplying this out, we get 28 over x to the 122nd over 42 times y to the 4 thirds, and this is the simplified expression. Alright, so that's example 1. Now let's move on to example 2 for the day. So example 2, we have 5x squared, x to the 7th, y cubed, y to the 3 over 2, b to the 4 over 3, divided by x to the 3 over 4, y to the 2/3, 5b squared, b to the 2 over 3. So again, we're just going to repeat the same step we did last time. So first let's take the real numbers, as we have 5 over 5, which is equal to 1. Next, let's take the x's. So we have for the x's, we have x squared over x to the 7th divided by x to the 3 over 4. So here, we can use the product rule to simplify the numerator, as we have x to the 2 times x to the 7th equals x to the 2 plus 7 equals x to the 9th. Giving us x to the 9th over x to the 3/4. Next, we must use the quotient rule to simplify this further. So we have x to the 9th minus 3 over 4, and now we need a common denominator. So we have 9 over 1 and negative 3 over 4. So if we multiply the top and bottom of 9 over 1 by 4, we get 36 over 4 minus 3 over 4, giving us 33 over 4. And this is the simplified x variable. So now we must move on to y. So for y, we have y cubed times y to the 3 over 2 divided by y to the 2/3. Again, let's start with the numerator and use the product rule. So we have y to the 3 plus 3 over 2. We need a like denominator. So we have 3 over 1 and 3 over 2. If we multiply the top and bottom of 3 over 1 by 2, we get 6 over 2. And then we can add 3 over 2 to give us 9 over 2. That means that this can be written as y to the 9 over 2 divided by y to the 2/3. And here we use the quotient rule. So we do y to the 9 over 2 minus 2 over 3. And again, we need like the common denominator. So we multiply 9 over 2 by 3 on the top and bottom, giving us 27 over 6. And negative 2 over 3 by 2 on the top and the bottom, giving us negative 4 over 6. Performing this operation gives us 23 over 6. So we have y to the 23 over 6 as the simplified y variable. Finally, we'll be on to b. So for b, we have b to the 4/3 divided by b squared times b to the 2/3. Now this time, since we have two terms in the denominator, that's where we're going to start. So we're just going to use the simple product rule of b2 plus 2 over 3. Here, we again need like the common denominator, so we'll multiply 2 over 1 by 3 on the top and bottom, giving us 6 over 3 plus 2 over 3, giving us 8 over 3. So we have b to the 4/3 divided by b to the 8/3. Here we can do b to the 4/3 minus 8 over 3 equals b to the negative 4/3, giving us b to the negative 4/3. And then finally, using the inverse rule, we have b to negative 4/3 equals 1 over b to the 4/3. Now when we put the real number, the x variable, the y variable, and v variable together, we will have the simplified form. So we will have 1 times x to the 33 over 4 times y to the 23 over 6 times 1 over b to the 4/3, giving us x to the 33 over 4 y times y to the 23 over 6 over b to the 4/3 as the simplified expression. Alright, with that done, we're going to move on to the last example for the day. So here we have example 3. We have a 7x to the 4/3 divided by 4x squared times 4y to the 9 over 2 divided by 7y squared times y to the 3 over 2 divided by 2 times x to the y to the 1/2 squared over xy to the 1/2 times 5xy to the negative 1/2 over x squared times 2. Alright, so before we go with anything now, we will have to take these three terms and distribute the exponents. So we'll move the 2 to the x and to the y, the 1/2 to the x and to the y, the negative 1/2 to the 5 to the x and to the y. So let's move this down. We have x squared times y. Since y, 1/2 times 2 equals y, or plus 2 equals y. Here we have x to the 1/2, y to the 1/2. And here we will have 5 to the negative 1/2, x to the negative 1/2, and y to the negative 1/2. Alright, with this simplified, we can now move on to separating the variables and the real numbers. So first, like always, let's start with the real numbers. We have 7 over 4 times 4 over 7 times 1 over 2 times 5 to the negative 1/2 divided by 2. First things first, we need to take the 5 to the negative 1/2 and we need to move that to the denominator by using the negative inverse rule. This will give us 7 over 4 times 4 over 7 times 1/2 times 1 over 5 to the 1/2 times 2. 5 to the 1/2 is equivalent to the square root of 5. Alright, now if we multiply this all out, we can cancel these 7s, cancel these 4s, giving us 1 over 4 square root of 5 as the simplified real numbers. Alright, next we're going to move on to x. So for x we have x to the 4/3 times x squared times x to the negative 1/2 divided by x squared times x to the 1/2 times x squared. Alright, so first we're going to deal with we're going to first use the product rule to simplify the numerator. So you have x to the 4/3 plus 2 minus 1/2. Let's deal with 2 minus 1/2 first. So first we need a common denominator. So let's multiply 2 to the top and bottom of 2 over 1, giving us 4 over 2 minus 1/2, which equals 3 over 2. So then we have x to the 4/3 plus 3 over 2. So again, here we need common denominators between 4/3 and 3 over 2. So multiply 4 over 3 by 2 on the top and the bottom, and 3 over 2 by 3 on the top and the bottom, giving us 8 over 6 plus 9 over 6, or 17 over 6. And that's going to be the simplified numerator. So we'll have x to the 17th over 6 on the numerator. So now let's move to the denominator. So in the denominator we have x squared plus 1/2 plus 2. So here again, all we're going to need to do is get a common denominator between 1/2 and 2. So multiplying 2 over 1 by 2 on the top and bottom gives us 1/2 plus 4 over 2, or 5 over 2. Next we have x squared plus 5 over 2. And here, again, 2 over 1 plus 5 over 2, just need to find the common denominator. So multiply 2 and 2 on the top and the bottom, giving us 4 over 2 plus 5 over 2, or 9 over 2 for the x. So this is the denominator, so we'll move it x 17 over 6 divided by x 9 over 2. And here, we'll use the quotient rule. So this will be simplified as x to the 17 over 6 minus 9 over 2. And here, what we're going to need to do is common denominator again. So 17 over 6 minus 9 over 2, multiply 3 on the numerator and denominator, giving us 17 over 6 minus 27 over 6. This is equal to x to the negative 10 over 6. And using the inverse rule of x to the negative 1 equals 1 over x, this can be written as 1 over x to the 10 over 6. Alright, finally what we need to do is move on to the y variable. So for y, we have y to the 9 over 2 times y to the 3 over 2 times y to the negative 1/2 divided by y squared times y to the 1/2. So first, let's start with the numerator. We have y to the 9 over 2 plus 3 over 2 plus 1 minus 1/2. So let's solve on the left this time. Let's do 9 over 2 plus 3 over 2, giving us 12 over 2. So we have y to the 12 over 2 plus 1 minus 1/2. So we can write 12 over 2, and we can simplify this as 6, giving us y to the 6 plus 1 minus 1/2. 6 plus 1 is 7, so y to the 7th minus 1/2. We must now find common denominators again. So we have 7 over 1, negative 1/2, multiply 2 to the top and bottom to give us 14 over 2 minus 1/2, or just simply 13 over 2. So this is the simplified numerator for the y variable. So we'll have y to the 13 over 2 in the numerator. The denominator for us is thankfully very simple. It's just y squared plus 1/2. So we just have one addition to deal with here. So we'll have 2 over 1 plus 1/2, multiply 2 on the top of the bottom to give us 4 over 2 plus 1/2, equaling 5 over 2 as the denominator. Yes, 5 over 2, sorry. So we'll have y to the 13 over 2 divided by y to the 5 over 2. And now we can simplify this using the quotient rule. So we have y to the 13 over 2 minus 5 over 2. Here we have a like denominator, so there is no reason for us to change anything. So we can just subtract it, giving us y to the 8 over 2, which can be reduced to y to the 4th. And this is the simplified y variable. So now we can finish this off by putting all of them together. So we will have the real number of 1 over 4 times the square root of 5 times 1 over x to the 10 over 16th times y to the 4th. Now multiplying this all together, we will have y to the 4th over 4 to the square root of 5 times x to the 10 root 16. Now, before we stop here, let's go ahead and rationalize this denominator. We're just going to achieve this by just multiplying it by the square root of 5 on both the top and the bottom. So when we multiply this by the square root of 5, we get square root of 5, y to the 4th, over 4, square root of 5, square root of 5, x 10 to the 16th. The square root of 5 times the square root of 5 can be written as just 5. So we have square root of 5 times y to the 4th over 4 times 5 times x to the 10 over 16. And finally, by multiplying 4 by 5, we will have square root of 5 times y to the 4th over 20, x to the 10th over 16th. Our last step to do is going to be to reduce x to the 10 over 16 into x to the 5 over 3. Excuse me. Into x to the 5 over 8. So by doing that, we can finish the simplified expression as square root of 5 times y to the 4th divided by 20 x to the 5/8. And this right here is the simplified form of the expression. So that's going to be all for today, everyone. Thanks for watching.